Yeah.
We'll go ahead and get things started then. Good?
Yeah, I'm good.
Alright. It's 6:35, so we should probably get things kicked off. And you can hit transition. I can hit transition. Thank you, sir.
You also need to refresh this shit.
Okay. Someone want to close that door right there?
Yeah, that's it.
Alright, so welcome to meeting 53. Talking about that cross-site request forgery, that then their topic there. No one here is new. Announcements. Okay, as a lot of you guys know, we have a lot more workstations in the lab, like 16, I think 12 are ours. So we yesterday went through and unboxed a lot of them, and we stacked them up on some foam, and we took out a lot of the old foam from stuff and cleaned up and consolidated some trash in the lab. So things are looking really nice. I think Ryan was going to look into wireways and stuff for managing wires. So I guess in the coming weeks, we're going to be hooking everything up, trying to figure out how we want to hook everything up. And I highly, highly recommend that if you guys have any ideas spinning on how to manage a lot of systems effectively and their configurations, you do some research and come prepared, because it's going to be fun. We're just going to sit down and we're just going to hash out what we want to do. This is awesome. Our lab is really coming along. Dr. Silvertooth, I said this last week, but he wants to come talk to us. I reached out to him today and said that maybe we could try a couple weeks from now. He was going to try to meet with us Friday, but it's Memorial Day weekend. I know a lot of you might be going home to your families or what have not. I don't want to have Dr. Silvertooth come down here and give a small talk. So I propose that we either do a WebEx kind of talk with him, where he talks to us over the interwebs, or maybe try to push this off for the fall and see if he would like to come in and talk to a larger body of students, or maybe both. We'll see. But if you guys have any thoughts or opinions on this, just let me know. But that'd be awesome. He works in the NCCIC, which is like the Cyber Operations Center, which monitors a lot of the United States. They're always watching for the big botnet attacks and whatnot. This is big, and all of you guys are invited to go to this because we're all a part of this. Even though the invite, like they've been sending out to people, has been talking about OCR at UC. So it seems that the Ohio Cyber Range at UC is the main focus of this event. But we're going to be there, and we're going to show them what we have going on if they want to see it. Because what we're doing is still pretty cool, and the coolest thing about us is that we are hands off. No one's telling us what to do, and we're completely grassroots, student-led, by the students, for the students, of the students. And if we can show up and show our presence and talk to them about some of the cool stuff we're doing with our lab and what we plan to do, that'd be awesome. So that's here on campus, May 29th at 9 a.m. You guys could just let me know if you want to come and meet with me. I requested off the day of work, or at least a half day of work for that. But it'd be awesome. We can get together and maybe network with some really high up people, which is always good to do. And the partnership with Galwa is still in the works. I've just been so busy. I could use help reaching out to all of these people and keeping on them. But yeah, that was a while ago. Does anyone else have any interesting announcements or anything maybe that they've been working on? No? Are we still waiting on the Northrop Grumman stuff? Okay, cool. Public affairs, ain't nothing there. And we're going to go to Corey. Get on this weekly content.
I'm going to be trying something just a little bit new this week. I prepared more articles that I'm going to share for you guys. And I'll just read the headlines for the ones I'm not going to share. If you want, you can check them out later. This first one, it's a vulnerability report for BMW cars. They hired this Chinese sub company called Keen Security Lab. They are actually the ones who did a lot of testing on Tesla's self-driving features. They had a report, I think it was like last year or maybe last fall. And they came back, they spent the last year auditing these BMW cars' software, and they came back with 14 vulnerabilities. Honestly, if that's literally all they found, that's pretty good in my opinion, but whatever. So they've got a technical report. It's like 26 pages long, which isn't that bad for 14 vulnerabilities, but it's not super detailed on the technical side on how to do these because BMW is still trying to get these patches out to all of their different vehicles. But they expect to release a full detailed report on exactly how to do everything sometime early 2019. They mainly focused on 3 different areas of the vehicle software. The first one, they called it infotainment. That's where like your music sound system, your internet connectivity for like, I don't know if you can stream like TV to your car or something. I don't know.
Probably these days.
All that stuff. There was the telematics control, which is like a diagnostics, or I'm sorry, that's the wrong one. This is like accident assistance, phone call making, that sort of thing. And then the last one is this gateway module, which is all about taking diagnostics for those 2 features and sending that information through a CAN bus up to the rest of the car. They described it in the article as kind of being the spine of this car's body in a software sense, I guess. So within each of these 3 features, they found 8 vulnerabilities in the infotainment system, 4 in the telematic control unit, and 2 in the gateway module. These 2 in the gateway module are really key because that's actually what would allow an attacker to theoretically take control over the entire software section of this car. So if there's like some sort of like self-driving feature, maybe they could make a turn. Obviously, if you're currently steering the car, there's probably contingencies in place to prevent, it from like forcing you into another car or something like that. But within reason, they are apparently able to take control over a car, maybe change your music, stuff like that pretty easily. So 4 of these flaws require a direct USB or maintenance port connection. 4 others require physical access to the car, but you don't necessarily need to be in it. And another 6 can actually occur remotely, either through a cellular network or through Bluetooth. If you want to read a little bit more detail on each of those, in the notes for this slide, I have links to everything. This next one, a new variant of Spectre is out. So for anyone who's not really familiar with the variants, when we heard about Spectre, we were also hearing about Meltdown.
Yeah.
So Spectre was actually variants 1 and 2 of Spectre, and Meltdown was just the 3rd variant of Spectre. And apparently they found a couple more vulnerabilities that could occur through the same process that the other Spectres use, which is something called speculative execution. For anyone who doesn't know what speculative execution is, basically your processor, when it's getting ready to perform some actions, it comes across something that maybe it's going to take a little bit more time, but it has a rough idea, like normally, like 90% of the time, say, we're probably going to get this answer for this process, so I'm just going to go ahead and I'm going to make a guess that that's what it's going to be, and I'm going to execute instructions as if that's what I got back, and then when I actually get an answer back, I'm going to compare and say, oh yes, I guessed correctly, and I'm going to continue executing from there. If not, I'm going to throw all of that into the garbage, and I'm going to continue my execution with the other answer. This is really important in modern processors for keeping them fast. The problem is that as soon as we patch these, you start to see performance hits, and so even though there are updates on the way, you are actually seeing, because it is somewhat difficult to take advantage of these exploits, and I'll get into why in just a second, you've actually got some people like AMD who are saying that you should probably not turn on these patches because when they come in, they're actually going to be off by default. So what they were the reason why they suggest doing this is because most browsers have already received patches that can prevent exploits like this coming, and that's really the only foreseeable attack vector for these, because they are so reliant on these language-based runtime environments like JavaScript, and the only way they can really see them getting in is through web browsers. So again, people like AMD are saying just don't do it. Don't take the performance hit on your CPUs. Like for example, Intel during their testing of the patch was getting anywhere between 2 and 8% performance hits. So I actually have in the notes here, sorry. Oh, because this is actually the first time I've found a video. This was made by Red Hat. There's actually a link to the entire Red Hat article on this, but they've got a really good 3-minute video here that I really suggest you guys check out. This is the first really decent explanation of Spectre that I've been able to find that's not like 4 or 5 pages. It's 3 minutes, you sure?
Yeah, it's 3 minutes.
Okay.
Okay.
Do we have sound somehow?
No. You gotta tell me if you need sound.
Sorry.
We need sound.
What do we do?
I need sound now.
We need closed
Too
captions.
late for that.
Closed captions. And full screen that. Let's just see what they're reading. See if it's good.
Yeah.
It's better be good. I'm gonna demand a refund.
Actually, I can hear it a little bit from the speakers. Try and hit the volume.
Oh, check the
Just are ready to help with this new threat.
There we go.
So what makes speculative?
It's not too loud back there, is it?
Computer security threat that lets cyber criminals steal sensitive information through any web browser is giving you deja vu? You're not alone. Many are comparing this new issue, known as speculative store buffer bypass, to the Spectre and Meltdown threats in early 2018. And just like when Spectre and Meltdown were announced, software patches are ready to help with this new threat. So what makes speculative store buffer bypass different? Imagine your computer is a restaurant. Waiters move from table to table writing down orders, called stores, in their ticket booklets. Think of these booklets as memory buffers that allow them to serve several tables more efficiently. At some point, a waiter will go to a shared station to transfer orders from his booklet to his customers' bills. He may decide to print out some bills in advance to have them ready, but to do this, he has to speculate that he's the only one serving his customers. Usually he's right, but sometimes a customer will flag out a different waiter and ask to add something else. The new waiter adds the item to the order, but now the printed bill is incorrect. When it's time to pay, the first waiter double checks and sees that his customer's order no longer matches the printed bill. He throws the old bill out and prints out a new one. A similar process is going on in your actual computer, where processors are like those busy waiters, storing data to and loading data from memory addresses. They are buffering requests and using speculative execution to make sure all this happens as quickly as possible. In order to avoid errors, the processors will double check if any address used in a load was part of a recent store to that same address. If so, the speculative data gets thrown out, just like our waiter threw out the incorrect bill. The problem is, this speculation occurs in a shared, unsecured area, so it's possible for unauthorized users to see it. This allows an attacker to create a malicious piece of code that fools the processor into reading from one address while it thinks it's reading from somewhere else. By tricking the processor, attackers can steal data like passwords and credit card numbers undetected. So how can you protect yourself against a threat that doesn't look like a threat? Technology companies have come together again to create patches that turn off speculative execution for store buffers. This stops unauthorized users from exploiting this vulnerability. It's critical to install these patches right away and stay up to date with the latest releases of operating systems. This will reduce performance slightly for some operations, but not as significantly as the patches for Spectre and Meltdown. Patches will continue to be optimized to reduce the impact on performance even more, and future hardware designs will eliminate this vulnerability altogether. New technology threats aren't deja vu. They're a continuing challenge we all need to deal with. That's why it's essential to keep the lines of communication open among technology companies, communities, and researchers to head off threats before they become huge problems.
Yeah, so one thing is Spectre, while it was pretty cross-processor, Meltdown, on the other hand.
You have
Whoa.
the YouTube video open or something?
Is the YouTube video open?
Here, wait, you have another window of Chrome.
I do.
Yeah.
I guess.
Yeah, go here and close it. No, wait. Okay, that's fine.
Anywho.
Close enough.
So, I just thought that was just a really great, just quick explanation for how Spectre works. One thing is this was actually found by Microsoft and Google working together. Previous Spectre and Meltdown variants were found just by Google 0 Day. I think that was. Oh yes, this variant is affecting Intel, AMD, IBM, and ARM processors, whereas Meltdown was pretty much just Intel. Spectre, I believe, was all of these as well, though. Just keep an eye out for those updates, I guess. So this next one, just how secure is your city? I have a link to the actual PDF of this in the notes, so
By
that'll
the
be
way,
up soon.
the slides the notes don't get shared, so I put the links on the website.
Okay.
Just so people know that's where they are.
Mm-hmm. So where was I? Oh, right. So this group, Coronet, a cloud security vendor, decided to go to public metro areas specifically for some of the most populated metros, 55 of the most populated metros in the U.S., and they compared the general security of Wi-Fi networks and public networks and so on in those areas, and they set up this little risk factor scale, and Las Vegas was the worst city in the U.S. for their public network security. They were a 10 out of 10, 10 being like grandparents level of cybersecurity awareness.
I had a good time in Vegas. I was poking around.
Yeah, probably. I bet you did. But they rated a 6.5 or less as being acceptable. And if you look here, I've got the worst 10 on that first point, and then the second point is the top 5 best cybersecurity cities. And if you notice that by the time we reach number 5, we're already at 6.3.
Mm-hmm.
So that's probably a pretty good sign that most of them are not an acceptable level of risk.
What's their risk? Like how do they define that?
Well, aside from my spelling error, they take in a couple of factors. The password protection on the networks. They evaluate like how secure a network is, you know, like WPA, WPA2, stuff like that. The entire paper goes a lot more in depth on how they go about evaluating it.
Mm-hmm.
It's actually a fairly quick read. It's a lot of like infographics, and it's only like 20 pages, but the actual text is probably like 5 or 6.
Okay.
So that just might be a fun little thing to check out, especially if you know someone who lives in one of these cities. Just be like, hey, you do realize that you've got almost a 50% chance of connecting to a high-risk network, right? So I'm just going to kind of gloss over these last two so we can get on with the rest of the meeting. Zipper Down, it's a vulnerability in mobile applications. They refuse at this point to release any technical details about how it actually works. But if an attacker has access to or control over the Wi-Fi you're connected to, and you're running one of these infected apps, they can run whatever application they want in the background, I guess. And like 10% of iOS apps are vulnerable to it, and a bunch of Android ones too. And don't share the where. Your phone companies are actively selling your real-time suspected location to whatever third party can afford them, with little to no accountability on how well protected that data is.
Yep.
So if you want to know more about those, feel free to check out these slides and the notes.
One way to stop this is to remove the SIM card and never. But So beyond that, beyond just the SIM card, removing that, you could turn off your device's GPS. You can try to turn off its network, remove the SIM card. Doesn't matter if you're running a Qualcomm chip. Qualcomm chips have location built into the hardware of the chip. So there's nothing you can do. They're always going to track you so long as you're using a Qualcomm chip. They can track you anywhere.
And then I guess the last thing, somebody performed a fraudulent SIM swap. They convinced a T-Mobile employee that they were the customer. And the entire goal of it, behind getting access to this guy's phone, was so that he could reset his Instagram account, so that he could change his username, so that he could then steal his 3-letter Instagram username account. Because apparently that's a business.
This has happened before.
You can sell 3-letter usernames for a good deal of money, apparently.
You guys heard of this happened with the Twitter user N, just N. That's his whole username. He got his website, like his GoDaddy account, hacked and everything, and it was like the guy was like, either you give me this account or I'm going to delete like your website, and it was like 15 years of blog and stuff or whatever. And so he gave up the account. He got it back later, but the guy actually managed to steal twitter.com/n.
Yeah. Part of the problem is T-Mobile's policy is when you get a SIM card swap, is they send you a text message, but they do it after the SIM card swap has occurred, so it just goes to the new phone. So that's really useful. And then Instagram, you can apparently just do a password change just by having the phone that's got the Instagram account connected to it, and like literally nothing else.
Wow.
So, yeah. I guess if you want to know more about those, check out the links.
Hey, it's me. Alright, so today we're talking about cross-site request forgeries, which is CSRF, CSRF, whatever you want to call it. This is sort of in the same vein of vulnerabilities as XSS, if you guys were here for that talk. So what is it? It's an attack where basically a malicious website tricks your browser, or doesn't really. Tricks is kind of giving it more credit than it's worth. It runs a request to another website and makes the request on your behalf. So it's like the most serious case would be if a bank website had a CSRF vulnerability, then another website would send a request to your bank saying, "Hey, transfer $5 million to this account," and your bank would be like, "Okay," and then you'd have a bad day. And so it can in some cases work even if JavaScript's disabled. It happens entirely in the background. It's not much you can do about it. It has been on the decline. It's no longer in the OWASP top 10 anymore, but it's still pretty popular. I think the most recent data I saw was that in 2016 there were 86 CVEs with it. So it's definitely not gone, though it is less prevalent than it used to be. And so some of the companies that have been hit, YouTube, Netflix, McAfee, and Facebook, ING Direct had it. They were an actual bank that had this vulnerability. A bank being vulnerable to this is like sort of like the cliche example people use to explain this. But an actual bank was vulnerable to this, where someone could steal money from your account. It blows my mind. Never. This was 10 years ago. Never bank with them. I don't even care. That is unforgivable. I have links to info about all these on the website. So, the way this basically works is like when you make a legitimate request on your bank, like you make a legitimate transfer request or something like that. You fill out a form and click submit, and it goes via JavaScript or the form tag. It gets sent in an HTTP request, and and when it does that, all your cookies and stuff are attached to it. And so even if you're on a different site, if a request is made, all your cookies and whatnot are still attached to it, so it still appears to be coming from you. And there are plenty of legitimate reasons to do this. For example, like if you want to embed an image from another site, then you just drop in an image tag and put the URL like imager.com/whatever.jpg, and it's completely legitimate. But if you type in here, it's like I'm gonna just open Notepad. This is easier typed than said. Can you tell I started working on this demo today? So it's like oh, come on.
So it's like if your bank, when you made a request, let's hope they use HTTPS actually. Like if your bank, when you made a request, it's like transfer money.php question amount equals, oh, please go on 2 lines. Okay, I'm just going to put in line breaks. Equals $5 million and destination equals account number 123. It's like if this is what the URL is when you on your bank click transfer money, it's like if someone on a malicious website made an image tag and said, hey, load an image from this URL, and your browser doesn't know that that's not an image. It'll try and load it, and then it won't load as an image, but you already made the request. It doesn't matter that the image doesn't load. And you can also do this. You could also have it so that it's like a script tag. You could have it as a CSS sheet, or you could write JavaScript code that makes an AJAX request to the site, and that could also do it. Which is what you have to do if it's there's 2 types of requests. I'm not going to go into get versus post, but there's some cases where you have to do it in JavaScript. But yeah, so that's how that would work here. Don't save. Yeah, I already talked about this. So yeah, the big issue is that when you're a developer, you have to assume that making a request and having your cookies attached to it is not a privileged thing, and a lot of developers just forget this. And so, demo time. I keep talking about this bank website. I made a bank website. If you want to go to unsafe. It's just this part of the URL right here. It is a bank website.
Oh, I got it.
That is vulnerable. And so your objective is to make your own website. And I'm going to suggest you do this on CodePen, which is just a site where you can prototype stuff. You want to write your own HTML that will steal money from someone's account. So you'll probably want to create 2 accounts. And to create an account, literally just make up an email address and type it in. Sign in. You don't even need a password. And then that account now exists and it's yours. So I'd suggest you make a target account and a your account, and you try and transfer money from the person who's logged in account to your evil account. So here I can show if I log in here. I've actually already been logged in with my email, so I'll be missing some money. You'll start with $1,000. So this is the site, and yeah. So there's a form here to make a transfer, and so you're going to want to see if you can run this form from your own website, which is, I suggest you do in CodePen because that's just an easy way to prototype stuff.
So CodePen, and you say new pen?
Yeah. I've also got a link to CodePen in the help page on the site. It's just a place to prototype HTML and JavaScript and stuff, which you shouldn't need JavaScript for this one. Originally, I had you doing JavaScript, and then I realized something was blocking it.
So we have 2 different accounts.
Well, yeah, I figure you're going to be signed into your browser on the target account, but then you'll also want to have another account, which is where you're sending it to.
Just signed in the same browser?
You can't be signed in twice. You might open an incognito window, or you might create the account, log out, and then switch to your target account. So yeah, if do you guys all know how to use the developer tools in your browser? That's because that's where you end up needing to go with this.
Okay, check this out. Let's see.
If you're wondering, H and Y is hopefully not your, because if this is your bank, you're in trouble. Please laugh. I tried really hard. Please laugh at my joke.
Here, I'll put this back up.
I like that they apparently just gave everyone $1,000 for making
Yeah, it's a good bank. You know, it's a good bank at first. You get drawn in by that. That's how they get you hooked, and then you realize that you only have that $1,000 until someone steals it, which they do very easily.
So can you grab the requests and the inspect? Like,
Yeah, and you can also just look at how that form is set up, because my code is not. A lot of websites have really ugly code. Mine's pretty simple because I made this in like 4 hours. So you can probably just read the code and figure out what the request looks like. Oh, nope, don't want to do that.
so this is something we script into one of the fields.
You wanna make a web, like, imagine this is like you're making like your own website, and you wanna have it so that anyone who visits your website, if they happen to have an account at HNY Bank, then they will instantly transfer some sum of money to your account whenever they visit your website. And this is actually, I have you doing it on CodeBin, but it's literally like if you have a site that lets you put, like, have an avatar that has a URL, like lets you put your own URL. Like, imagine if Twitter let you specify the URL for your avatar, then you could make it so that anyone who visited your Twitter profile sends you money. Fortunately, Twitter does not do that, and also no banks are vulnerable to this anymore. But yeah, I would like to think, at least I hope banks are not using GET request, which is the ones that you can do with an image tag. If you're doing any request where there's a transaction that happens, where something changes on the website, you're supposed to use post request, which is not used when you load an image. So you can't just embed an image to it. You have to run JavaScript code. So that adds a little bit of safety there. Because the problem with GET request, the other thing is that it's like, if you sent someone $10 and then you accidentally refresh the page with a GET request, you'd end up sending them another $10. I actually had to do to make this site use GET request. I actually had to do some silliness to make it not do that when you refresh the page. You know, I didn't test what happens if you send money to yourself.
It adds the amount of money to. I just did that.
Does it? Can you get infinite money that way?
Yeah, infinite money.
That's hilarious. I did not think to block that. I thought to block sending someone a negative amount of money so that you couldn't just have them send you money. I did think to block that one at least. And you can't send more money than you have in your account. But I forgot about that one. Did someone send? I don't remember doing something with 10 cents. Did someone send me money or take money from me? I hope you can't take money from me. I think Yeah, I think there shouldn't be a vulnerability there, but yeah.
So you have it in the code pen, but how do you test if it's working?
So then you'll go back to the site and see if your balance has changed.
If you have CodePen,
Yeah. So like on the CodePen, you have your whatever you're doing to make the transfer happen, and then you go back and see if it changed your balance. It should have lowered your balance in theory if it worked.
you did butt at nut. I did butt at booty. And butt at butt. No lie. Like refresh this page. I just refreshed it.
Yeah, so here I'm not showing you my solution, but I did it over on this other screen, and now if I refresh, I just lost $100. And every time I hit save or refresh this page, I lose another $100. Huh? Sorry?
Now that's what I call a money pit.
Yeah. So has anyone managed to steal from themselves yet? Anyone have any
Chris
loss?
has working one.
Oh, you do?
Yeah.
Nice, nice.
Can't you just like put in stuff and just send it?
Huh? Yeah, but the trick is to make it so that like it's just like an innocuous website. What?
Yeah.
Yeah, exactly. Like literally, you could copy the link to your CodePen, paste it in Slack. Someone else could click it, and it would work. It would steal money from their account instead of yours. That's the real catch with this. Yeah, is the CodePen you're generating. It doesn't just work on your computer. It works on anyone's computer as long as they have an H&Y bank account. It'll steal from their account and send it to yours.
So how did you craft that?
Craft what?
I want to know how he got this.
He sent you the
Well, yeah, that's the thing.
butt@nut.com.
Yeah.
I wonder how much money this account has yet. The good thing is people can steal your money. If you know their email address, you can just steal it back by logging. Wow, you've collected a lot of money. Yeah, but AJ only had $1,000 to give you.
Exactly.
You're a bad bank, David.
Yeah. I'm a deliberately bad bank though, except for the part where you can give yourself money. That was not intentional. That was just a fuck up. Butt@nut.com is so funny to me. So yeah, I don't know. Do you guys want me to show how it's done? Do you want to
Yes.
work on it a little longer? Or?
Show me.
All right. So
No.
let's pop the developer tools open and let's inspect this thing. And so oftentimes, actually, in this case, I think it's a lot more useful instead of having the tree here to just use the view source, which is on Windows it's Control U, on Mac it's Control Shift U, on Linux. I don't know, you use Linux, you can figure it out. So this lets you just see it in a flat view instead of having it in all the trees where you have to open all the little sub things. And so you can see we've got a form
So it's going to index.php. So if we want, here, let me open Notepad over here. Let's make the font a little smaller. So we know that the URL is going to be index.php, which is already the URL we're at. So this is going to be the start of our request. I'm just going to put in line breaks where I need to. And then, so the first input we see, the name of it is email. So that means we're going to have an attribute called email. And so to start the parameters, you put a question mark, and then you say email equals the email you want to go to. Here, I'll put it like this. And then so we keep going through here. The next input is this number field, and its name is amount. So we're going to say the first one you delimit with a question mark. Everyone after that is an ampersand. That's just how URLs work. And so it's ampersand, and we want to take $1,000, say. And then the last thing is that the submit button is also an input field, and its name is transfer. And so we just have to say transfer equals anything.
So, interesting. Okay.
And so if we connect to this URL.
So you work by name, not type.
Huh?
You work by the name, not the type.
Yeah, yeah. So if we type in this URL, it will initiate a transfer. Oh, I just gave myself $1,000. I forgot about that bug. But so yeah, that's the format of the URL that you want to put in basically, and that's how you find it.
So when you're passing things in the URL, you delimit the first thing you pass by question mark.
Yep. When it's doing parameters in this
And
key.
How do you know that those are what's being passed just by looking at this?
Yeah, yeah. So you can see whenever you have inputs, that's like a standard HTML field, and the name is always going to be the same as the name that appears here. That's what the name attribute does.
So whenever you have an input, you have a type and a name.
Yeah. And the type doesn't matter for this at all. It doesn't relate to what gets sent to the server.
Yeah.
If you give it a negative number.
Huh?
What happens if you give it a negative number?
Well, let's find out.
So then anybody else that visits that will send $1,000 if they. Why does that work if they have an account? Like, is it just cached?
Because it's sending the request from their browser, which means all their cookies are attached to it.
So they would theoretically have to be.
This is what happens when you try and transfer a negative amount. Yeah. One step ahead of you. Wasn't one step ahead of AJ giving himself money.
Magic money.
I gave myself money, but I couldn't figure it out. It's because I don't know what's URL stuff.
Yeah. Web stuff is
Can you pass like 150 grand or something to it and see what
if you try and pass more than is in your account, it will also stop you.
And this works because of the. This works because of cookies. And because requests made by your browsers will have your cookies and will come from your IP address, and so the website will have no reason to suspect that they're legitimate unless they prevent it, which I guess awesome segue right here. So the way you prevent this is you use something called CSRF tokens, and it's basically in your form here. You would have, in addition to like the number field and the email field, you would have another one of type hidden, which means it's one that the user can't change, the user doesn't see, and it would be called like token or something, and it would just be like a big long random string, and you wouldn't accept a request that didn't pass that string back. And the idea is, even though when you visit like evil.com, they can send a request to your site, request anyone can do. They can't see the response from it. They can't see what the server sent back. They can make that request. Like when you load an image with like an image tag, like img source equals whatever. I should go back to Notepad. So like you can load this image from this site, but you cannot like actually access the data from that site. And the same thing if you do it in JavaScript, which I'll show you what that looks like. What?
So this is what it looks like to make the request in JavaScript. And it's like normally when you do this, you'll get back some data from the site. But if the site doesn't, if you send a request to another website and that website doesn't specifically have headers set that say anyone can access this site, then JavaScript will throw an error when you do this. And I can actually show that off here. So like let's see if I do. Oh, jQuery is not available. Let's go to CodePen. And I can get jQuery real fast here. Let's see. Oh, I gotta do HTTPS. So we can see right here, failed to load this URL because access control allow origin, because example.com did not pass a header saying you can access this URL remotely. But the reason my browser makes the request, because it doesn't know if the site's gonna say you can't make this request until it's already made the request. It doesn't know, so it makes the request and then it finds out, oh, okay, this site doesn't allow it, so we won't give the response to the application. So your browser does have that bit of security where it won't let you read the contents of some random other site, but it will let you make the request, because if you don't make the request, you don't know if you're allowed to make the request or not. So
the access control allow origin header is what is required to...
Yeah, like if you're going to run a public API that you want people to be able to access from other websites, then you'll set this header and allow all origins, which means all domain names, and then this request won't fail. So that's the purpose of that.
And that's what's used just to mitigate it, no matter what.
Yeah. But the default is to not allow it. But it's just, you have to be able to make requests, because like imagine if your browser had to assume that if you I'm putting this in the wrong field, like if you put in like an Imager URL, that like it had to assume that Imager wasn't going to allow you to download that URL, like nothing would work. You'd only be able to host your own images, your own script files and stuff. And so the web has to work this way, and it's on the developers to properly use CSRF tokens. And nowadays, pretty much every framework you ever use, it will have a system like for automating the building of forms. You're not going to be manually typing the HTML for that, and it will, without you even doing anything, put in CSRF tokens and make sure all your requests require that.
So CSRF tokens you put in a type hidden field that is required to be passed on the GET request.
Yes.
And that is something.
Or on a post request, either way.
Post or GET, either one's hitting the website, and that is a hidden string that is not visible by the user.
Yeah.
Because it's in type hidden.
Yeah. It doesn't have to be hidden. It's just why would you show the user a random string?
Yeah. So.
And generally, you also make it so that it only every time it's used, it expires. So it's one time use.
Yeah,
so in case
if it was more than one time use, it'd be pointless, because then you can just do CSRF with that token, it never changes.
Well, no. The only way you could get the token is if the user accidentally leaked it somehow. Like they sent you their HTML or something. They posted their HTML online or something. That's the only way you could get that token.
So each user has a unique token that's given to them.
Yeah, it's unique to every user and every request. It's generated. The token probably changes if on this page, every time I would hit refresh, I'd probably, holy crap. Every time I'd hit refresh, a really secure site would probably give me a new CSRF token every single time I'm hitting refresh here.
And that's an HTML element?
Huh?
CSRF tokens?
It's just, I can literally, here, let me pop this into Notepad. That is way too big.
Didn't you only start with 1,000?
Comic Sans.
No, veto.
Comic Sans.
Veto. Let's see. You can't all right, whatever. We're just gonna deal with it being indented. So it'd literally be input type equals hidden, name equals CSRF token value equals blah.
And why will that stop somebody from?
Because the person cannot. You can like make
you
this.
Just put that as an ampersand and then pass that value.
Yes, but you don't know that token. You, the attacker, putting an image on some other site, you don't know what this token is.
You don't know what the token is for them.
Yeah.
To make the GET request to do that. Okay, because everyone has. Okay. But if
Everyone has a unique token, and it expires like immediately.
But you as a sender can know what your token is when you're sending.
You can know what you know what your own token is, but you don't know what anyone else's token is. So this you could attack yourself, but I mean that's not really attacking.
Interesting.
Yeah.
I didn't know about this.
Yeah. It's a little bit more obscure because it's just it doesn't it just comes up less because the only sites that have critical enough commands that you can run to do this are generally secure enough to not be vulnerable to this nowadays. Because this you can't like read data with this. It's like write only. Like you're changing something. You can't even tell if your attack succeeded except by checking your bank balance or whatever.
So ING had this with money orders.
With
so
money,
I literally just have a URL crafted for a GET or a POST request to transfer some X amount of money to anybody who clicked your link to some account.
Yes. Although it was probably, I'm gonna guess they use post request, which means you would have to do it with an AJAX request, which makes it.
What's an AJAX request?
An AJAX request is when you with JavaScript make a request to URL like.
Okay.
An AJAX request looks like if you're using jQuery, which is just a library that makes the web suck less.
Can't you just use curls?
Not in JavaScript. AJAX is like is sort of like the curl of JavaScript is how you could think of it.
Oh, okay.
JavaScript is like the most sandboxed language ever because it's code that runs just by someone like typing in a URL. So like there's no trust in JavaScript, so everything's really sandbox. So you can use this library jQuery because it's written entirely in JavaScript. But yeah, this is what it looks like to do it from JavaScript. And like the way you do a post request is you'd say method equals post, and then you'd say data equals, and like for the site we had, it'd be like amount equals 500.
This is like the exact same.
Yeah, and it'd be
syntax as a post request. So just the AJAX. Okay.
Yeah. So yeah, this is what it would look like as an AJAX request. And so this is the advantages. You can do post requests. You can do stuff like that. You can have more control over it. But this tends to be a little bit more locked down. Like I don't know if Chrome has changed something where they block CSRF attacks with this, or if I just was doing something stupid. But actually, originally I had it, so this was post, and it was post only, and I was gonna have you guys write this JavaScript, but it wasn't working, so I changed it at the last second.
Oh.
So. What?
How would you go about writing this? Like, if you didn't want to try and rely on like their current browser's cookies, but you wanted to try and take, say, like maybe the username from their current whatever they're looking at this link through. Is there a way to do that?
Are you talking about if you're the attacker?
Well, for example, so I want to write like a script or whatever that's going to make this request. Say I'm going to put the link in like my Twitter profile or something. So whenever someone looks at my Twitter profile, so say, hey, here's the visitors. I don't know their username or whatever. So I'm going to take their username.
If you are able to run JavaScript on the page, then you can do that. But you can't really retrieve a variable from a page. Just if like Twitter let you like embed a profile picture from an outside URL, then that's just like a static URL. You can't have that URL change, and so you could maybe if you had the URL to a server you control, you could see in the server logs the IP address of people who visited your Twitter profile, but you wouldn't be able to know their Twitter username.
Okay.
Yeah. Does anyone else have questions?
Wait, you can track peep people who visit your Twitter page?
No, I was saying if Twitter was silly and they made it so that instead of you uploading a photo to them for your profile picture, if they let you just say, here's the URL to my profile picture, then you could put in a URL to a server you own, and then you'd be able to log every time that picture got downloaded, which would then tell you every time someone visited your Twitter profile.
Interesting.
Which is why Twitter doesn't do that. But like if you go on like old forums, like PHP BB forums from like 10 years ago or whatever, they often would let you put in the URL to your avatar. Or like if you go on forums, like you can put images in your signature and stuff like that. Or like all sorts of stuff like that. So there are plenty of places where you can embed an image or whatever, and that lets you track people who have seen that image. So.
Damn.
Yeah.
I've never seen CodePen.io too. That's cool.
Yeah, it's just a nice. There's a bunch of sites like this. Another one is JSPen, and they're all just. Actually, I probably should have had you get. I kind of. This one's a little bit cleaner, I think, in some ways. But yeah, there's just these nice sites for testing web stuff. You'll see a lot of anytime someone wants to demo like a cool new proof of concept that they did in CSS or whatever, you'll tend to see them put it on CodePen. So yeah. Yeah, that's all I got. I don't know if anyone has any more questions or
Thank you.
Yeah, sure.
That was really cool.
Yeah, thanks. Thank you guys.
Yeah, dude, that was great.
Good job on short level.
Yeah.
Yeah.
I had plenty of notice. I just put it off. I knew, like, I almost did this presentation last week, and then I was just like, I'm not going to have time. Someone please cover me. And Chris, fortunately, had material ready. And then I was like, cool, I've got a whole week. I'll have a whole week to make this presentation awesome. And then I started on it earlier today.
So, cool.
Yeah.
So, I guess at this point, we're pretty much done with the main part of our meeting. If any of y'all want, you can come over and see what the lab looks like after some of our work. But yeah, at this point, you have the key.
Yeah.
So you're the man for that.
Oh yeah, you guys probably didn't get to go last week because I had left early.
so definitely, please let me know if you want to go to the open house Tuesday. Because that'd be awesome.
I asked Grace, we talked at the last executive meeting since you two are here, and you weren't here for me. I asked Grace to post today, after the meeting, the bylaws.
We all read over it.
Just because on Sunday, we're going to take any recommended changes to those bylaws. We'll probably do it Sunday and maybe even the following Sunday, a couple of weeks of looking at those bylaws. I wanted to warn you that I am going to be actively asking for recommended changes by I'll put it in Slack also, and I figured I'll put it out to all the members.
Hayden, did you have everybody's Gmails?
No one has sent me their Gmail, so.
Oh, you want my Gmail? For what?
I posted in the execs channel so that I could share the Google Doc and give people editing permission.
It's for the bylaws, so everybody can make comments on them.
Oh, yeah. Yeah.
I wanted instead of just making it a public link, I wanted people to give me their email so the comments would be from so and so instead of from anonymous leprechaun or whatever.
Yeah, anonymous. Cool. All right. So we good?